Okay, so in today's lesson, we're going to step up the difficulty one step notcher, increase it by one notch. So you know all the exponent rules. Now we're going to integrate those exponent rules with BEDMAS, which you learned last year, right? So if you don't remember, you guys remember BEDMAS, right? The acronym? There's a couple different acronyms that teachers may use. What did the B stand for in BEDMAS? Biman? Brackets. What did the E stand for? Brayden?
Exponents.
Thank you. What did the D stand for? Dylan? Division. And M? Conveyor?
Multiplication.
Multiplication. A? Brayden?
Adding.
And S, interpret?
Subtraction.
Adding and subtracting. Okay, so this told you the order to do operations when you saw them. So first comes brackets, second comes exponents, now third is division and multiplication. So those are kind of tied, right? You can do them basically in any order unless you're trying to have to do a tiebreaker between those two, and I'll talk about that. So I'm not sure if your previous year teacher may have talked about that. Okay, let's go like I'll change that to a 6. Let's do a 3. Okay, looking at the top one there, the order that you do things sometimes makes a difference. And if you're choosing between multiplication and division, which one to do first, and they're right next to each other in these kind of situations, you read it, you do them left to right as you would read it, right? So in this case, you go 12 times 6 on the top, then you divide by 2, right? You don't go 6 divided by 2 first, then go times by 12, right? At the end of the day, in these both cases, it will give you the same answer, but in some cases it won't. So if you have to choose, you read from left to right, whatever comes first on the left-hand side. And the second one comes 12 divided by 6 times 3, so you do the division before the multiplication, because the division came first. Now, that is the basic math rules. That's the convention which math is written in. I think it's lazy, right? So every year, if you're on social media, something always goes viral. It's usually a math question, and it'll be like, hey, what's the answer to this equation? Some people will be like, it's 6, other people it's 11, no, it's minus 1. It's because the equation that they put up, right? Yes, there's only one correct answer if you follow the correct order of math operations, but it can be ambiguous, and people don't know what to do first, right? So in real life, in practice, you wouldn't, if the order of the operation matters, like if you're a professional, you don't write it like this, right? Because it leads to confusion and it leads to mistakes, right? What you would do is, if you want somebody to division first, you would rewrite this statement as like that, right? Or if I wanted somebody to do the multiplication first, I'd write on the bottom, I'd write it like that. So the brackets tell you have to do it first. That's what you do professionally when you get older, right? However, in textbooks, you're in grade 9, and they go, we want to make sure you know all the rules. So we're going to put all the different rules in and all different kind of configurations, and just make sure you know how, all right? And some of them are not based in reality of how you would see it. The only time I can see that you wouldn't use brackets in situations like this is if you are in maybe doing computer programming, if that's the path you want to go, where each character adds up memory and space, and it affects how fast you can run routines and stuff like that. But other than that, if you're not programming, I don't really know if there'd be a real life situation where that's the go-to route for you. Okay, so I'll say that. So I will assign some of those questions because it's in your textbook, and depending on who you get next year, they may be a textbook kind of person, so that you need to be familiar with that. But in general, when you have a test or a quiz from me, I will use brackets because that's just common sense. Okay. So let's do a few examples using exponent rules and brackets. All right. The first ones are easier, then they get increasing in difficulty. Right. So just looking at example A, 1A there. What would we do first? David?
The brackets.
The brackets. And so there's nothing inside of the bracket, so just a -2 right there, right? Then what do we do after that? Ranveer?
Exponent.
Exponent. So we go to the exponent. Okay, the exponent applies to that bracket. So -2 cubed in brackets, which becomes what when we clean that up? What does that simplify to? Jacob, do you know?
Would it be -8?
Yeah. So that becomes -8. So that's 6. The 6 is still there, and we just cleaned up everything that was highlighted there to -8. So we have 6 times -8. And we use our calculator for that. What's 6 times -8? Kabir?
48.
-48. Right? Awesome. Okay. Try B, C, D, and E. Apply the same rules there. See what you come up with. And I'm going to just put up the answers. Alright, it's going to be very similar to the one we just did. Right, so I'll give you like a 30-second, not even a 15-second head start from me, then I'll start putting up the answers and just look up and confirm, and if you're having troubles, you can just follow along. Alright, I'll give you a couple of second head start, and I'll just continue do them. Alright. So these are just two-step questions, right? So there's not too many steps on them. So the stuff that if you look up on the board, the stuff that I highlighted is the first step, right? And then you can see what that simplifies because I highlighted that as well, right? So now, looking at these, compare that to your answer. Is there any one of these that you're like, hey, Mr. Jalal, how the heck did you do that? I don't understand that. That you want me to talk you through? These ones are pretty straightforward. Takes time, but pretty straightforward. Okay. So the next stage gets a little bit more difficult. Okay? Is when we throw adding and subtracting into it. All right? Now, to help with these ones, I'm going to walk you guys through these because they're pretty nasty looking. You need to be able to look at them and chunk them into pieces. And if you find this easy, go ahead, go in front of me and start doing it. And I'll talk through the rest of the class if you're finding it hard. Right? So when you look at bed mass, the last two things that you do are adding and subtracting. So we're going to use the adding and subtracting to break the expression up into smaller chunks. So whenever we see adding and subtracting not a part of brackets, I'm going to highlight it, or you can put a little arrow next to it, because that's going to break up our chunks of calculations. I'm going to put a 1 there, and I'm going to just look at these. I'm going to go all the way down. I'm going to put a highlight that, and I'm going to highlight that. I'm going to highlight this, and I'm going to highlight this. Okay? Remember, adding and subtracting, as long as it's not part of the brackets, that's going to be one of the last things we do. So we can use that to separate things around. Or you can put little arrows, because you probably don't have highlighters, put little arrows to separate those out of how we're going to break these up. Right? Then we look on either side of those addition subtraction symbols, and we start simplifying those. All right? So we look at the left side of here, looking at A. How can we simplify that? What is 4 squared? Use your calculator if you can't do that in your head. 4 times 4, 16. Okay? And we write down our plus sign. Then we go, hey, let's clean up the next one. This one's a little bit harder to do. Negative 4 squared in brackets. What would that simplify to? Negative 4 with a square. Go ahead.
16.
Close.
Negative 16?
Negative 16. Because that negative is not attached to the exponent, right? So it'd be negative 16. Now, you can go 16 plus negative 16, or you can just rewrite that as 16 minus 16, right? A positive and a negative combined together to make a negative, right? Which is equal to 0. All right? Okay. So for B, I've already done it, but the first step you want to do is look for your pluses and your minuses. That's going to tell you how to chunk it, as long as it's not part of a bracket. So I highlight them, draw an arrow, and then we look on either side of those to clean it up. So the first one here, to the left of that subtraction, is 5 squared. 5 squared, right? Which is 25. Right? I'll highlight that in blue. Minus so you look in between the two signs. We have a minus and a plus sign. So in between there, what do we have? We have 10 divided by 2. What is 10 divided by 2? What is this? 5. Yeah. So that would be 5. I write down my 5, and I'll highlight that in green. All right. Then we have a plus sign. Okay. Then we have the last one. Is very similar. It's identical to the one above. Negative 4 squared in brackets. So that was negative 16. So plus negative 16, or maybe we can write this as just negative 16 or minus 16 here. Minus 16. right? And I'll highlight that in purple. Okay, so now we've broken this ugly looking expression into 3 parts, and we simplified those 3 parts separately. Now we go to the last part of BEDMAS, which is the addition and subtraction. All right, and we just clean it up. Riley, do you have a calculator handy? Could you add and subtract these numbers for me? I don't have my calculator. Where is my calculator? You have one? Can you add these numbers together? Tell me what it equals.
Add them together.
Or subtract them. They're all subtracting. 25 minus 5 minus 16. What is that?
4.
4? Thank you. All right. Okay. The next one, C, gets a little bit more difficult. Okay. So we have our plus sign. So we're going to do the stuff to the left of it. Then we'll do the stuff to the right of it. Okay. Looking to the left of it is we have a number outside of our brackets, then followed by the brackets. So BEDMAS says we do the stuff inside the brackets first, right? So we have our -2, and we're going to clean up inside that bracket. So we have 16 minus 3 squared. Well, it goes BEDMAS, it goes brackets, then exponents. All right, so before we can subtract the 2 numbers, we need to take care of that exponent. So that becomes -16 minus 9. Okay. Then I'm going to write that plus sign in, and I'm going to continue on. That's the plus that I had highlighted. And once again, we have a number outside the bracket, so we're going to just leave that as is and clean up the stuff inside the brackets. We have 2 plus 1, which is a 3. Right? Squared. Still not a nice looking expression, so we're going to have to do this one more step, but it's a lot better than where we started from, right? And if you can do this, that's about as hard as it gets with these kind of questions, right? Okay. Appreciate your patience on this one. Okay. So once again, we're chunking. We're looking at the left of the positive sign, of the plus sign, and right of it. So we need to take care of what's inside these brackets. -16 minus 9, which is -25. Sorry, 20?
25.
25, right? Yeah. Sometimes my mental math is not the best. And we still have that plus sign. And on the other side, we have the 3 squared, which is 9. So we still have that 4 up front. We have 4 times 9. I'm going to put that into color code these things for you guys. And that came from the green. Just so you know where it came from. Okay. Now it becomes straightforward. Now this is like something you would look at in grade 8. -2 times -25 plus 4 times 9. Right? So this equals, looking at this one, -2 times -25 is 50, and 4 times 9 is 36. And combine those together is equal to 86. That was a lot of work. Did anybody do that without my help and get it correct? Oh, impressive. Impressive. Good, guys. All right? Okay. Do you want me to do the next one with you guys, or do you guys want to try it yourselves? How are you guys feeling? How do these look? A little tired? Need help? No? Okay. I'll give you guys a little moment.
For C, it was 86, right?
Yes.
Yeah, I did small errors.
It's so easy to make mistakes on these kind of questions.
Because it's like, there's, for some reason did the adding. I added 50 and 4 instead of multiplying 4 and bracket 9. But I fixed it.
Yeah.
I think I did it.
Good. Alright. So the more practice you do, the more you get to see like how this thing chunks, and then it makes it easier. It's like, okay, I'm going to do this chunk first, and I'm going to do that chunk second, right? So I'm going to do this next one now. I know some of you guys already done it. Right? So looking to the left of the subtraction is we want to do the stuff outside the brackets first. 5 plus 2 is 7. So we have 8 times 7 squared. Right? Then we have our minus sign. And we have 12 divided by 2 squared. We need to do the exponent first. So we have 12 and 2 squared is 4. Okay. Okay. Then we have to do the exponent. So that's 8 times 7 squared, which is 49. So we left with 8 times 49. Maybe we'll go like this. That becomes that. And we do the minus sign. And 12 divided by 4 is 3. So all that becomes 3.
8 times 49 is 392.
Is 392?
Yep.
Thank you. Minus 3
3. 3.
equals 389. Thank you. We're going to skip example 3. I don't think we need to do that one. Okay. So I know this is a big step up in difficulty from what you were doing the other day. So don't expect a lot of these questions on the test. You'll get 1 or 2. Right?
Way too many steps.
Oh, sorry?
It's just way too many steps.
Yeah, and it's way too many steps and easy to make an error in one of those steps. Yes. Go ahead.
Are these questions gonna be like in the format where it's a story, like Thomas did something like that?
Word problem?
Yeah, word problem.
Word problems. Possibly. That's the next
No.
the next question.
I don't like word problems.
I know. Most people don't. Right? Because you need to have a good grasp of the English language, then the math combined to be able to do it. Okay, so I'm going to example 4, then we're going to do, I think, maybe example 5, and we're going to call it for this set of homework, so we can do a little break and give you some time to do some homework. Let's read this first, because it's a doozy. The cube sum of 4 and 2 is decreased by the square of the product of 5 and 3. Write the expression and solve. Okay? Okay, so let's start off with the cube. So we're going to cube something. What does cubing something mean, David?
Having the exponent of 3.
Having an exponent of 3. So we're going to have to have an exponent of 3 to something. And it says, yes, David. Yeah. What about 4 and 2?
4 times 2.
No.
Oh, sum. So
It says sum of 4.
plus
4 plus 2. Now, if you get confused of what sum is or product is or quotient is, look up on the wall here above the chalkboard. So product and multiply means multiplication, and you have quotient and divide there. You have all the terms there. So you just take advantage of what you can see in the room to help remind you. Okay? Then it says, is decreased. What does decreasing mean? Jacob?
Subtracting.
It's subtracting, taking away, removing. So we're going to subtract. Okay? By the square of something. So what does taking the square of something mean? Isaiah?
Exponent of 2.
Exponent of 2. So something with exponent of 2. We'll fill in the blank for later. What is that something? Okay? And then it says the product of 5 and 3. Biman?
5 times 3.
5 minus.
5 times 3. Yeah. Right. Yeah. 5 times 3. So that is your algebraic expression. Next step, solve it. So apply your BEDMAS. I'll give you like, I don't know, 15 seconds here. It's an easier one. And you compare your number to what I'm going to show up here on the screen here. All right. Okay.
Four
Yes.
plus 2 would be 6.
Yes, thank you. Thank you. Okay, so hopefully you came up with -9. Yeah, awesome. Yeah, this is more like a realistic question. The other ones is more like, can you? It's a challenging question. Can you do it? All right. Okay. Okay. Next word problem. Before we do a homework break here. Okay, write an expression with powers to determine the difference between the area of large square and a small square of those given lengths. What is the difference? So it's asking us for Mohit.
Oh, difference is subtract.
Difference is subtracting. All right. So what are we subtracting? What is the question asking us to subtract, Jacob?
7 squared and 5 squared.
You did one step ahead of me. I just want to make you're not incorrect. You're not correct. Sorry, you're not wrong. So I'm using too many double negatives there, confusing myself. Bimin?
7 minus 5.
No. It is 7 squared minus 5 squared. But what I was trying to get at, David?
The area of the large square minus the small square.
Yeah, the area of the large square minus 5 square. And you guys are great. You're just thinking one step ahead of me, right? But for the people who large square minus area of small square, right? And yeah, Jacob, you're completely correct, right? How did you come up with 7 squared?
So if it's a square, then it would be like the 7 centimeters is the sideline.
Yeah.
So that would be squared for the area.
Yeah.
And that's the same thing for
Yeah.
the small square.
So remember for area for a square, it's just your length times your width, or your side squared. So 7 times 7, right? So that'd be 7 squared. That's where that came from, right? And the other one, exact same reasoning. We have a 5 and a 5 minus 5 squared. 7 squared minus 5 squared, right? So what would this equal? 7 squared minus 5 squared. So that'd be 49 minus 25, which is 24. That's right. I should be able to do that. Now, if I was doing this and I wrote this answer down, it'd be near perfect. I would probably end up taking out half a mark. What am I missing from this? What should I include? Kabir?
After the 24, you put centimeters squared.
Centimeters squared, yeah. So if in the question you're using dimensions, right? And so those need to show up in your final answer. So their length is given in centimeters, right? And if you're talking about area, areas are always square centimeters, so centimeters squared, or whatever the unit is squared. If you're talking about meters, it'll be meters squared. And if the question is talking about volume, it's cubic. Your units are cubic. Okay? So let's